Welcome to Chile, Munich, and where we'll be talking about creating AR and VR applications with Qt. So, first, allow me to introduce myself. My name is OLAV TVETE, but you can just call me Paul. I'm a software engineer at the Fire Emoji graphics engine Fire Emoji team at the Qt company's Oslo office. And that is the official team name, by the way. So I've been using Qt since 1995. I knew the founders of Trolltech from university, and they hired me in 1996, which was around Qt 096 times, making me the only person with code in all 7 major versions of Qt. So I'm going to fast forward through 29 years of Qt history. If you're interested in Qt history, Eirik Ovisland will have a great talk about the history of graphics of Qt in the main stage later today. Currently, I'm working on Qt Wayland. I'm maintaining the commercial add-on Qt Server. I've been working on the curve renderer for Qt Quick Shapes. Really nifty piece of technology. Go visit the developer desk outside the main stage if you want to know more about that. And for the purpose of this talk, I'm in the Qt Quick 3D project and most importantly the XR project. But enough about me. Let's talk about you. I assume you're here because you're interested in AR and VR. I'm going to assume a basic knowledge of Qt and QML. But if you don't know Qt Quick 3D, I'm going to try to explain what I'm using. What I hope you're going to get out of this is how to do XR with Qt, and also what Qt can do for you, what we provide. So, the agenda for this talk, we're going to start with showing how to create 3D scenes in XR. Then we're going to look at adding 2-dimensional user interface QML standard Qt controls things to an XR application. Then we're going to look at augmented reality or AR. Finally, we're going to look at how to do artificial locomotion. And then we're going to end up with a question and answer session. So please save your question for last. So first, let's start by defining our terms. There are so many abbreviations and names floating around, but I like to think about 3 main aspects. One is you build a complete virtual world and you place the user inside that. That's the classic VR. Then you show the real world and you put virtual items around in that world. That's augmented reality or AR. There's another aspect, which is taking a real object and mirroring it in the virtual world. Prime example is having a real steering wheel in a driving simulator. If you've ever tried that, you know that's an immensely immersive feeling that you feel with your hands what you see in the virtual world. There's something else also called AR, which is when you take your phone up and you see the camera view of that phone on the screen, but you also see that there are Pokemon or whatever around in that world. This is not what I'm talking about. We are experimenting with that in the Qt company, but we don't have anything ready to show you quite yet. So this is going to be a fairly quick walk through a broad range of topics. So it's going to be slightly fast, but don't worry if you don't catch everything, because I will share the slides and all the example code with you afterwards. So let's look at Qt Quick 3D first. This is not the Qt Quick 3D talk. If you're interested in how to do fancy things with Qt Quick 3D, please go and see Andy's talk on the main stage tomorrow. Well, he will be showing really interesting tips and tricks. This will be absolutely bare bones code showing the principles of XR, but 90 to 95% of what you write in an XR application will be plain Qt Quick 3D code. So let's just start by making the simplest possible 3D application we can. So let's go to sketchfab.com and download the 3D model. I found this nice picture of a fantasy scene. Then we're going to run the Balsam tool that ships with Qt, that translates the model we download into QML and the other supporting files that Qt is going to need. Then we're going to make a short QML file. And once we have that, we can just use the QML tool that ships with Qt on the command line without compiling a single line of code and show you. So let me show you real quick. Pretend I'm typing this up now. Pardon the mess. So the main things we are going to need in our application is we're going to need a window. It's going to show up on the screen, like it's a windowing system after all, so you need a window. Inside that window, we place a Qt Quick item called View 3D, which is a two-dimensional item that's showing a view of the 3D world we're making. We're setting up a little bit of environment, we're setting up lighting, and then we place the perspective camera. This is the node that's going to show you. The View 3D is going to show what this camera is looking at. So we position it in 3 dimensions, and we give it a rotation looking slightly down. And then the medieval fantasy book is the item that Balsam made for us. When we run this, it's going to look like this. So that is the very short introduction to Qt Quick 3D. So let's unwrap our shiny new VR headset and let's get started with the XR. So the 2 fundamental types that you're going to need in XR is the XR view. The XR view is the container for the entire 3D world. And then it's XR origin, which positions the user's viewpoint within that world. It's not precisely the same as the camera, because, I mean, if you're wearing a headset, you can move around and look at things from different places, but the origin doesn't actually move when the user moves around. So the origin is the 0 point of your view. So let's look at how we would transform our 2D or flat screen application into an XR application. So the green square says, the first step, of course, to say that we want to use the XR module. Then we're going to replace the window and the View 3D with the XR view. In this case, we're using the local reference space, which is, we're going to come back to that later, but the local reference space is the point the headset was at when the user pressed the center view button in their user interface. The environment, the lighting, the content all stay the same. And then we replace the perspective camera with the XR origin. Note that we do not rotate the XR origin. The camera, we tilt it down to give a slightly downward view of the model. If the user wants to look down in VR, they can just look down. We don't rotate the camera for the user. So when we run this, it will look like this, and I can look around at the model from different directions. So, yeah, apologies if you look seasick. I mean, it looks completely natural when you... This is why it's so hard to demo VR, because it never looks the same on the screen as it looks in the headset. I promised you to talk about reference spaces. We have 3 different reference spaces that you can choose between in Quick 3D XR. So, as I said, the local reference space is where the headset was when the user reset their view. This is what I used here because it was just a model floating in space. This is what you would use if you have just a 3D model that's not connected to anything. You just want to show 3D information that the user can look at easily. The other one is the stage. So if the user has defined a safe area to walk around in, then the stage reference space has its 0 point in the middle of that space. This is the reference space you want to use if the user can walk around, interact with things here, interact with things there, and no single point is really more important than any other. So the local floor is the position on the floor. The 0 point of the local floor reference space is just below the local space reference point. So if you don't know which reference space you want, you probably want local floor. This is for seated experiences, for instance, the user, and when things are actually placed relative to the floor, it will not feel natural unless you have the floor as your reference space point, because the user can tell that the floor he's seeing is not the same as the floor he's feeling. And the other difference is that the stage reference space is set when the user maps out their safe area. It doesn't change when you reset the view. The local and local floor reference spaces, they will change when the user resets the view. So, things to take note of when making VR applications. One is the scale of what you're making is important. When you import a model, sometimes it's one unit is 1 centimeter, sometimes one unit is 1 millimeter, sometimes one unit is 1 meter. If you're making a flat screen 3D application, having a 5 centimeter car with a camera 5 centimeters away, or a 5 meter car with a camera 5 meters away is going to look exactly the same. In VR, it's going to be immediately obvious if you have a toy car this close to your face or a real-size car out there. So make sure you keep the scale right. The other thing is performance is critical. If you skip a frame or two in a normal application, it's going to look slightly unprofessional, but no big deal. If you have too low a frame rate in VR, people are going to be actually sick. So optimize your assets and be careful. Don't use, or be very careful using expensive techniques such as reflection, refraction, and real-time shadows. Couple of technical details. If you already have a 3D application that you want to translate into Qt 3D XR, if you have custom shaders, they will need to be modified for multi-view. Details in the documentation, or ask me. Also, if you're using a skybox for the background, you need to replace that with a skybox cube map, because the skybox takes some shortcuts that are visible in VR. Sorry. That is all you need to do to make a 3D scene in VR. Okay, are we done yet? No. But you probably want your 3D scene to be interactive as well. So let's look at controllers. So with the controller, you can move it around, and our API provides one type, which is called XR controller, which is a tracked node, which is, that is to say, the system determines the position and orientation of it. You instantiate it, you don't set the position of it yourself, you just can read out the position, or you can create children of it, which will then move with relative to that position. The other tracked node we have is the XR camera, which is more of an abstract camera. It's not the camera that is rendered. It is a position in between the eyes of the user. It allows you to track what the user is looking at, where the user's head position is. So let's make a scene. No, not that way. Let's make an application that uses these concepts. So we go to Sketchfab again, download this nice flashlight model, and we create an XR controller, and inside, as children of that XR controller, we position the flashlight model that we got from Sketchfab. We also position a spotlight. This is going to give the illusion that the flashlight is actually shining a light. And then, just because we can, we also add another spotlight 15 centimeters above the XR camera. This is going to look like I have a headlamp on my head, approximately 15 centimeters. Okay, maybe it's a helmet with a headlight on it like this. So if I run this one, it's going to look like this. If you look, you see the white light here is following my head movement. You can't see my hand, but trust me, that flashlight is following my hand movement. So that is how to track movement of controllers. But these controllers have lots of buttons and joysticks or whatever, and we want to react to them. So for that, we have the Action API. One type, it's an XR input action. For that, we have the action ID. Sorry, it says ID. I should have said action ID. Telling you what are we reacting to. Are we reacting to pressing a button? Are we reacting to the movement of the joystick or the the trigger or whatever. We get the information in three possible ways. We get a signal whenever a button is pressed. Whenever whatever we specify happens, we get a trigger signal. There's a pressed property, a Boolean property we can query and see whether the thing is active or not. And then for, if you look, the trigger here is analog and the thumbstick is analog. They will give you a value between 0 and 1 or between -1 and 1. Just for convenience, a Boolean property will also give a value of either 0 or 1, and an analog property will give false for less than 0.78-ish. I don't remember quite now, and 1 when it's maxed out. So let's make a quick scene using this. We're creating a controller. We call that right controller. Then we make one action for the joystick. You can see here we're actually using a list. This is because different platforms have different controllers. This controller has a thumbstick. Other controllers have a trackpad. Works slightly differently, but in this case, we can use it for the same. So this action, the joystick Y action, is going to react to both the trackpad and the thumbstick. And then finally, once the trigger is done, we're going to make a component that is written off screen, and I'm using the value of the joystick to calculate a size, a radius, and I'm using the position of the controller for the position. I will share the complete code for this example after the talk. So when I run this, it will look something like this. You can see I can create objects when I press the trigger, and I use the thumbstick to make the objects smaller or larger. So that is how to do controller input with Qt. Now, changing tax, we're going to, this controller doesn't work on the presentation. This controller works on the presentation. Two-dimensional user interfaces. Several reasons we want to do that. I mean, first of all, Qt controls is an established technology. We have loads of user interface components, so making two-dimensional user interfaces available inside the 3D world gives us a lot more features. Also, you probably already have a lot of dialogues and forms and whatever already written in Qt. So it would be very nice to be able to reuse that. Now, Qt 3D allows you to put 2D content directly in there. You don't need any specific XR for that. The only problem is that the default unit size in Qt is 1 unit, 1 centimeter. So unless you're making a billboard, you probably want to scale your user interface. So we give you the XR item that allows you to specify the physical size of your user interface independently from the logical pixel size of the user interface. The XR item also allows you to give touch events using hand tracking. We're going to come back to that. In addition, we have the XR virtual mouse, which allows you to get mouse events from just pointing with your controller at something and pressing a button. So the virtual mouse we use like this. First, we say we need a controller, and we need an action. So the controller we call right controller. The action is when we press the trigger on the right hand. Oops, I brought the wrong controller. And then within the XR virtual mouse, we just say the source, which is where we're pointing. We get that from the right controller. And the left mouse button is pressed when the trigger of that controller is pressed. You can also specify middle and right mouse buttons and even scroll wheels in the XR virtual mouse. The XR item. The XR item has a width and a height in centimeters, such the blue dashed line here. Inside the XR item, we put the content item, which is the 2D content. In this case, we make that a rounded rectangle. This is 200 by 250 pixels. So you can see the XR item is positioned and rotated in 3 dimensions. The content item is specified in two dimensions. And some people find this confusing, but it's not any more difficult than you might have a monitor which is 3,800 pixels wide, and it's also 50 centimeters wide at the same time. It's just 2 different systems of measurement. So let's make an application. Now we're going to yes, this is we're putting these things together, the input action, the virtual mouse, and the XR items. And as you can see, we get it running like that. The red line here is just something I put in to visualize where the controller is pointing. So that is controllers. Modern VR headsets allow you to track hands. So the easiest way to use hand tracking is to do almost nothing different, because hands are represented as controllers. Now, hands typically don't have buttons and joysticks, so we have some extra input IDs like pinch gestures, the index finger pinch, the middle finger pinch, ring finger pinch, and so on. The grip action like this is the same, uses the same ID as this grip action, actually. So that's the simple way. We also have the XR hand model that allows you to show a model of the hand in VR. This relies on a Quest-specific extension, so it's probably not available in all headsets at the moment. This is something we can probably add later. The Apple Vision Pro will show the real hands of the user, so the XR hand model would not be useful there. Then for touch events in XR, we have the process touch function inside XR views. So let's look quickly at how this might look. So the process touch functions takes the position of the hand, which we get from the hand tracking API, typically the tip of the index finger, although you can get the position of absolutely every bone in the hand if you really need it. And then we send that together with the ID. That's just an integer. I mean, since we support multi-touch, you can provide anything, any number here from you can do 2 fingers or you can do multiple fingers if you want to. The interesting thing here is that the process touch function returns the offset between the XR items. So if this is my XR item, and this is a virtual item, so nothing is going to stop my hand from going through there. But I will get the offset back if I now set the hand model's position to that offset. You will get the illusion that the hand stops at the surface, and that actually is fairly convincing that because you don't see your hand, you just see the model of your hand stopping. So let's see how this would look in practice. So here you see I'm visualizing the pointer. This now using XR mouse, that is the touch. And you see I'm getting 2 different IDs from left and right finger. And of course I can then use touch to interact with all the 2-dimensional user interfaces. So that is how to do 2-dimensional user interfaces in Qt. Now let's move on to augmented reality. So most headsets these days, they have cameras on the front. They will show on the screen a view of the world around you. And then the scene that we draw is just painted on top of that view. This is called pass-through. So there are just a couple of very simple APIs to do this. You can ask the XR view if it supports pass-through at all. Not all headsets have cameras after all. And then you have the pass-through enabled, which is a property you can set to true. Then you're going to see the real world around you, or false. Then you're just not going to see the real world. In order for this world to be actually visible, you need to set the background of your 3D scene to transparent. Otherwise, it will just draw the background color and you won't see anything. So the code for this will look something. This is a pattern I like to use. I define my own property, whether I would want to have pass-through or not. Then the user can turn this one off and on in preferences. And then I set pass-through enabled if the system supports pass-through and I want it. And then the important part, in my scene environment, I need to set the background mode to transparent. That's all you need to get an AR scene. And this is how I ended up with a giraffe in my office. Now, if you look carefully, you see this giraffe is just standing on the floor. It's not actually interacting with anything in the scene. If you want to place objects relative to something real in your environment, you need to use anchors. So an anchor is something that the headset knows about in the real world. It can be a table, it can be a wall, ceiling, screens, a cabinet. It's a three-dimensional item. It has, the classification is what sort of thing it is. Then it has a position. The extent is how big it is. The offset is the offset between the position and the center of the object. Just for convenience, the position is not the center of the object. It's on the surface of the object, because if you want to place something on the object, you want to, if I want to put something on this lectern, I want to put it on top of it. Don't want to put it in the middle. Well, I'm hiding stuff in the middle, but you can't see that. And that's the point. So that is why we have the offset in addition to the position. The way we show you, or we provide these anchors to you, is through the XR Spatial Anchor List Model, which is a data model in the model view sense. And I just have to apologize in advance. We use the word model to mean two completely different things. It's both the data model, which is a list of data, and it's also a three-dimensional model of things that we're showing in the scene. And it's just unfortunate that we use the same word for two completely different things, but no one talked to us before two different sets of people decided to use the same words. The anchor list model also has a classification filter. So say you're only interested in tables, you can ask, just give me a list of the tables, so then you don't have to filter it yourself using manual code. So let's look at what this scene might look like if we write it. This is, we make an anchor list model. We use the position and rotation from that. We use the classification to determine the color. And sorry, that's the other meaning of the word model. We're just using a cone to show you where each anchor is. So, and in the complete example, I'm also using a filter to put black squares on top of all my screens. Not because there's anything to hide on those screens or anything, but just for extra interest. That was how to do AR. Now, onto artificial locomotion. Fortunately, there are no new APIs you need to learn for this. The only thing you need to do to move the user through the virtual world is to change the position and orientation of XR origin. So just make a note that this is a feature we only provide for VR, because teleportation in AR is equivalent to teleportation in the real world, which is unfortunately outside the scope of Qt. So the simplest possible way to do useful movement in an application is to have multiple predefined viewpoints. Like sometimes you see this in architecture, like this is the view from the living room, this is the view from the staircase. So in 2D, we can do this very easily, and we can also make really nice, smooth transitions with just a few lines of QML. Now, don't do that in VR. Even if you're among the 2% of people who are completely immune to simulator sickness, I will guarantee you that 98% of your users will hate you. So instead, the most gentle mode is what I like to call blink teleport. So yeah, now is where I'm going to go faster through the code, because we don't have many minutes left, unfortunately. But main point here is I use an animation to fade out the view, then I change the location, then I fade in again, and I use an input action to change position on the trigger press. So it might look like something like this. So, a couple of warnings. The most important thing is only rotate around the y-axis. If you try to rotate the origin around any other axis, you will tilt the whole world. This will cause the user to lose a sense of balance. If the user is standing up, potentially catastrophic consequences. Don't do that. Also, be very careful. There are two separate rotation properties. Euler rotation is the one with 3 axes. Rotation, which is very tempting to use, is a quaternion, which is, I think it's a hyper-complex number or something like that. At least it is hard to understand. It has a y. If you change it, it's not going to end well. Don't ask me how I know this. So, to be kind to your users, avoid smooth rotation and acceleration. Prefer snap rotation, blink teleportation. Remember, people are different, so if you do other things, provide options. So, some practical information at the end. A lot of people will be using the MetaQuest, either this one or the slightly more expensive one, as opposed to the very expensive Apple one. So what you need is a development setup for Android, and you need to go into Android manifest.xml and do magic to say this is an XR application. The last minute bug report we got, don't use Vulkan for now, because there's something in the drivers of the MetaQuest that doesn't like what we're doing in Vulkan. So just stay with the defaults, use OpenGL for now. Fortunately, if you use Qt Creator 16, there is a ready-made project template. Go to New Project, Other Project, XR, and it will set up everything for you, including a setup for the Apple Vision Pros. We also have some helpers, work in progress, very work in progress, so they're put in examples for now, giving you a few helpful things that you can copy into your own applications. For instance, aim controller allows you to grab and move stuff around. XR gadget is a way to create components like resize and rotate handles. And we also have the freeform teleporter. Let's see if, okay, this is This is where suddenly my laptop decides it doesn't want to show me that video, but that is okay because this is the final slides before we have to go to questions and answers anyway, which I think is very soon. The Git repository that contains all the code I've shown you today.